Hello and welcome to my video, lesson 5.1, working with radicals. So here we have a couple of questions and some examples, and this is our first unit or first topic, working with radicals. So let's take a look here at the two different types of radicals that we look at. We look at mixed and we look at entire radicals. So what does that mean? Well, it's kind of like how with fractions we can have a fraction like 7 over 4, which we'd call an improper fraction. So basically, the entire thing is the fraction, and then the other one is the mixed fraction, which is where we'd have a 1 and then a 3 over 4. So both of those are the same value-wise. Let's just rewrite that out. Value-wise as each other, the improper and the mixed. But one is improper, one is a mixed fraction. So the same thing works with radicals, where we can simplify, arguably, an entire radical to make a mixed radical, or we could take a mixed radical to make an entire radical, because then potentially we can work with it more easily. So depending on the context, one might be more useful than the other, and we have to be able to switch back and forth from one to the next. So with that said, let's try these first two and see if we can switch back and forth. So the first one here is a mixed radical, because we have the 3 out in front. And so if we put that back inside, we'd have to square it. So to put it back inside, what we do is we go 6 times by 3 squared, right? And so now what we can do is go 6 times by 9, and so we can have that as 54 as our final answer. If you can get there faster without showing those intermediary steps, that's all right as well. I just want to make sure it's very, very clear while I'm doing it the first time. All right, the second one here is an entire radical. So what are we going to do with it? We have to actually split it up. And we're going to basically make a factor tree. So I know this can be divided by 4 and 8. And so I can then go 2, 2, oh boy, I should have added more room, 2 and 4, and then another 2 and 2. So if we now, yikes, sorry about that. Here, I can make more room for that. No problem. There you go. If we now circle the 2's, we have to group pairs of them. That's the key. We have to grab pairs, then we can take those out. So for example, we've just taken out 2 2's, so 2 times 2, done that twice, and we still have inside the 2 that was left over. So maybe I'll circle that with another color, purple here. This one's still left over, so that's why that's in there. So now if we simplify this one more step, we can go to 4 root 2. All right. So we now have gone both from a mixed radical to an entire radical, as well as an entire radical to now, at the end, a mixed radical. Both are valid, both are useful, just depending on the context of the question. Okay, let's take a look at these other questions here and see if you guys can try it. So the only thing I've done differently here is instead of having a square, we have or a square root, we have a cube root. So how's that going to change it? Go ahead and try it. Okay, hopefully you paused the video. If not, try it right now. Otherwise, you won't learn as much. So pause the video, try the question out, and then press play, and you will see how I do the question. All right, so we have a mixed radical and an entire radical. Now let's take a look at solving them. So what we're going to do with the mixed radical is just like before. So we have cube root 7 times by 2 to the 3. So the only difference is because we use square root, we use squaring, and because we're using cube root now, we're doing cubing. And so now we can get 7 times by 2 times 2 times 2 is 8. And so now we can go, this is cube root 7 times 8 is 856. Wow, that took a long time. Yikes. All right, here's our next part. This is an entire radical. We want to switch this to a mixed radical. The only thing that's kind of weird here is now we're using an x, but it's the same process as before. Let's see if you guys can get there. Just keep in mind that we'd have x times x, right? And we'd have x to the 7. Then we do x times x times x. Basically, there's 9 x's. Okay, that's the key. I'm going to rewrite it out differently to make it abundantly clear. So we have x times x times x times x. That's 4, 5, 6, 7, 8, 9. So now we have 9 x's. And so now we have to group them in what? How many per group? Groups of 3. So we have 1 here, we have 2 here, and we have our third group here. And actually, there's none left over. So we actually get to go straight to a nice even x to the 3, which really I should have made this a more challenging one. Had maybe I'll just show this. If we had x to the 10, what would we get? Well, we'd have x to the 3 cube root x. So hopefully that makes a little bit of sense. So if we had one extra one here, maybe I'll just do that in green. If we had one extra one here, it would still be left inside the cube root. Okay, so here's the last and hardest example for this topic here. So square root 128 and x to the 4. So what we're going to do is, first of all, find the factor tree of this guy, which is going to be, I don't know, so I'm going to put in what I can do, which is 2. Oh, I made it too easy. What am I doing here? Crazy person. Let's do it a little bit harder. Let's make this a 5. Yeah, let's make it a little bit harder. Okay, so anyways, we have a 5 there. So now we can go and split this up. So 32. Actually, let's give us a little bit more room. This is 2 and 64. This is 2 and 32. This is 2 and 16. This is 2 and 8. This is 2 and 4. And this is 2 and 2. All right, so yeah, they're grouped up. Let's make it 64. That'll work out better. I want to have a harder question. Excuse me. Okay, so the only thing that disappears is this. And so all of this stuff here just moves up to right about there. All right, so now we have a few groups of, oh no, it worked before. Oh my goodness. All right, so we have a whole bunch of 2's basically. We just need to pair them up. So we have one group here, one group here, one group here, and the leftover lonely 2 down here at the bottom. So maybe I'll just circle that so you can see. There's a leftover lonely 2 there. So sorry about that. So 2 times 2 times 2, those are our outside 2's, square root 2. And so now we still have left inside the x to the 5, but we can take out 4 of them, and leave in 1 and just take out 2. So you can kind of hopefully see how that happened in the same sort of way as before, or perhaps we could even write that out. Write that out a little bit more carefully so you guys can see it very, very clearly. All right, so we're going to take out the, we can multiply all those 2's together. We can take out bunches of 2's or groups of x's, sorry. So we can take out 2 of those groups. So we have x to the 2 and 2x, or x squared, sorry, and then square root 2x. All right, and the last thing I just want to mention very quickly is square root of -1 gives us an error. You can feel free to try this in your calculator, as I'm doing on the right. And you'll see that it gives you non-real answers. So this is not a real number. In fact, it is called an imaginary number. So fun fact there, and we can't have that. That'll mean that it does not work. All right, so I hope this video helped you understand working with radicals a little bit better, and good luck.